So now the question that we're going to try to explore is what happens if you do arithmetic operations like plus and minus or add and subtract on pointer variables. What happens? Well, let me give away one of the key important things to, or one of the key things to remember, which is um, uh, you cannot do multiply and divide on pointers. Okay, so let's get this out of the way. And you can only do pluses and minuses or addition or subtraction. And let's talk about what addition and subtraction means. So that was the first point, right? You cannot do multiplication, division on pointers. The second one was, oh, okay. The first one was you cannot do multiplication and division. You can only do addition and subtraction, right? And the second is an addition and subtraction. Uh, the increments in the pointer or the address, so to speak, will not be in terms of how much you add and how much you subtract. Okay, so like a plus one doesn't mean jump or move by 1 unit. Well, in this case, let's not call it unit, but 1 byte, and that will become clear. So these are the only two things I want you to remember. Um, so let's talk about an interesting case. So let's say we have int a, which is an array, let's say, of I don't know, 1, 2, 3, for example, right? And then we have character, which is b, 3, you know, a, b, and c, right? And then what we do is we say, hey, there is an int pointer, uh, int pointer pa, which is pointing to, okay, because it's an array in this case, it's pointing to a, right? And let's do this in the next case, which is, let's say we have a character pointer, which is, pb, and pb is pointing to actually the address of, let's say, the first element of b. So it's actually pointing to b. We'll draw visuals for this, which is, so we somewhere had a, and the first element here was 1, second was 2, third was 3, each of them 4 bytes on our machine, right? And then we somewhere also had, uh, so to speak, b, and we then had a, b, and c here. And this was like the 0th element, the first element, the second element, 0th, first, and the second element. And what we're then saying is, hey, go to um, the first element of B and get me the address of that and assign PB that value. And this is like very specific why we are doing this. So PB then is pointing here, while PA is pointing to here. Okay, now the question is, or the key point that I want you to remember, if we did PA plus 1, remember PA is pointing here, the 0th element of A. So when we do plus 1 here, this is very, very important. So if PA was pointing to, let's say, the memory address hex, not hex 10, but let's say hex 4, for example, if it was pointing, if this integer was at hex 4, the next integer would be at hex 8, and still next would be at hex c, right? For example, so a PA plus 1 doesn't mean, you know, hex 4 plus 1 byte. It actually means, and this is absolutely crucial, you get this right, and pointer arithmetic would always be a breeze for you. And what this really means is, don't increment it by 1 byte, but increment it by 1 into the size of the data type. This is absolutely crucial. So what will it change to? It will change to hex 4 plus 4 bytes. So it'll actually be pointing here now, right? And by the same logic, if we were to say, hey, what happens if I did PB plus 1? So PB is pointing here, right? Which is, let's say, again, um, let's just take hex 1 1, hex 1 2, and hex 1 3, because these are like 1 byte data. Character is 1 byte data, hence these addresses. Here, if you see, there is delta of 4. So, um, integer is of 4 bytes. All right, so we are then PB is hex 12, and in this case, a PB plus 1 actually means 1 into size of char or char, that happens to be 1, so it will be incremented to hex 13. So you see, same operation leads to different jumps in the pointer address or the pointer value. A character pointer, when incremented by 1, will move by 1 byte. An integer pointer, when incremented by 1, will move by 4 bytes, right? 4 or 2 bytes, depending on how much an int is on the machine. A short, for example, a short pointer, a short integer pointer, when incremented, will move by 2 bytes. When decremented, it goes back by 2 bytes. Similarly, if it was like a double pointer, then what I mean is, if it was a double data type, a pointer, then incrementing on this will move it forward by 8 bytes, and decrementing it would move it backwards by 8 bytes. Similarly, when you have a struct, if you have a struct pointer, right, if you have like int, float, another float, so let's say this is 12 bytes. So if you have a pointer to some struct, let's say XYZ, and this was XYZ. So a struct pointer, when incremented, will actually jump by the size of the struct, which is in this case 12 bytes, right? So it'll move forward by 12 bytes. If we increment it by 1, it'll go backwards by 12 bytes if we decrement it by 1. And you can increment and decrement by any integer value. It's just that be mindful or whether on that location, the new address, is there something meaningful, right? So let's come here. So we have PB, essentially holding hex 12. So if I were to increment this by 1, it becomes hex 13. If I decrement it by 1, it becomes hex 11. Right. And it's also fair to ask, hey, what happens if I increment it by, let's say, 3? So it's actually, pointing to hex 14, or holding the address hex 14, where you don't have anything useful, right? It's fair to point at that point. But when you dereference, you will get either garbage value, or you might get segmentation faults on an operating system based run, um, or your processor might hang if it's an embedded systems code. All bets are off. Anything can happen here if you're going to a location uh, where you don't know what data is, or even if you're allowed to go to that region or not. For the allocations that you have done in this case, we had 3 bytes worth of data being allocated, so we know that plus and minus 1 from this memory address hex 12, we had useful information. Outside of that, anything can happen, right? All right, so the key point again in this was that increments and decrements on pointers depend on the size of the data type that the pointer is for. If it was a character, +1 -1, +2 -2 is like 1 byte forward backwards, 2 bytes forward backwards. But in case of an int pointer, +1 +2 might mean +4 bytes to the original address, and +8 bytes, right? So 2 into size of integer, 1 into size of integer, that kind. And we'll again hammer this point home by taking a look at our example here. Let me get rid of this, and right. uh, okay, so here is my example. A is a character array, so we can anticipate addition on PA here would be incrementing by one byte, the address would be incrementing by 1 byte. PB here, which is pointing to int, will increment and decrement by 4 bytes. Uh, uh, we are pointing, PA is essentially pointing to start of A, which has again A, B, and C here. And similarly, somewhere there is B where PB is pointing to. We have 10, 11, 12, and then we have, um, you know, at the bottom somewhere there is PC, uh, and PC essentially um, is pointing to short int type of an array, and it's pointing to the second element here because of this code. So that is 21, 20, and 22. So PC is pointing here, right? And what I have here is to demonstrate math on char pointers, math on int pointers, and then math on short pointers, right? So let's go ahead then and kind of execute the code here. And the interesting bit would be here. This is just to show again, how the pointer arithmetic works. I have no, I have compiled the code, then followed by a dot out, and we see a lot of prints here. Again, go back to the explanation, and this is where, so if we had A here, A was at the location 445, you know, 445, and what we see here is the zeroth, like PA plus 0 is same as 445, PA plus 1 is 446, moved by 1 byte because it's a character pointer. PA plus 2 is 447, moved by 2 bytes from the original one. And what we are doing here is dereferencing, much like in previous videos, and we're essentially able to see A, B, and C. Now, at this point, I have to um, talk about one special thing that you would see here, which is a star P A plus 0 is equivalent to take PA and infer the first element, right, or zeroth element. So this notation here for a pointer, and this is very, very important. This For a pointer, this notation is same as, hey, go ahead and dereference from the original address the zeroth, like add 0 to it, and dereference that. So PA plus 1 here, right, would essentially mean same thing as PA brackets 1, and that is what you see here, right? So all this, both of them are printing the same value, right? Okay, so that said, now let's move on to pointer arithmetic on an integer. So PB then, which was, or B, which was, I suppose, 10, 11, and 12, 10, sorry, 11 and 12. So PB then is essentially, 438. Then when we add 1 to it, it doesn't increase to 439, it goes to 43C, which is an increment of 4 bytes. And then when you add 4 to 43C, becomes 440, which is same as, hey, add PB plus 2 into size of int, which happens to be 4 bytes for the size of int, which happens to be PB plus 8. And that's what we see here, right? And again, what I'm doing here is printing, using the square bracket indexing notation, and then the dereferencing with pointer arithmetic, and you see 10, 11, 12 being printed. The fun part is in this example where we are pointing at 434, which happens to be 21, right, which happens to be 21 as a short. And if you see minus 1 on it would mean that we decrement the address by the size of a short, which is 2 bytes, hence you see 432. When we increment it in the next kind of line, it goes to 436, right? And the point or the address being incremented or decremented is this. And the prints kind of give it away. Notice that 20 is here, 21 is here, and 22 is here. Right. So hopefully you're convinced about the pointer math so far. And just to prove the point that you cannot do multiplications, let me go ahead and enable one more line, which is this, which if you see, we are trying to do like a multiplication on a pointer, and that kind of, means kind of nothing for the compiler, because the compiler cannot understand it, and it'll go ahead and throw an error. So let me try and compile this code, and as you can see, it gives us an error. And similarly, you can kind of, try and divide, and that should also make no sense to the compiler, right? Let's go ahead and compile this. Doesn't work, right? So hopefully pointer arithmetic, the key point that I wanted to deliver was +1 and -1 is not like an increment and decrement by 1 byte. It's actually increment and decrement by 1 into size of the data type.